In today's FAQ with AGIQ, I'm going to give a very general and very high-level overview of the different types of compressors out there. We get asked a lot, and you're going to see a lot of different types of compressors in equipment. On-off, staged, digital, inverter, all different control methods for compressor capacity. And I'm just going to very high-level highlight what those are. Obviously, an on-off compressor has two modes, 0% and 100%. At 0%, the motor's not spinning, it's consuming zero energy, and at 100%, it is at its rated capacity. And there's absolutely nothing in between. It's a very efficient condition when it's operating at that rated point, but when you need to have variable control of a room, you end up just cycling that compressor. So it doesn't lead to particularly stable room conditions. This is the kind of compressor that you typically find in your car or your house. Just on off, you know that you hear it turn on, you hear it turn off when the set point is met, and you typically have a couple degree deadband there. A staged compressor typically has some kind of physical unloader and might be, a 50% stage and 100% stage, or a 65% and 100%. And that allows some variability in the overall mass flow through that compressor. But because it's a physical unloader, they're relatively cheap to produce, and they're very, very reliable. There's not a lot to go wrong in them. That said, they don't offer quite as good control as some of the other methods of variable capacity available out there. But there's a balance between cost, reliability, and control that you need to determine is appropriate for you and your facility. In terms of the two sort of more variable types available out there, one is a digital scroll. The digital scroll is effectively a pulse width modulation. It has a solenoid on the scroll module that opens and closes it. The motor stays running 100% of the time, so you don't see a huge amount of energy savings there, but you get very accurate control over mass flow when you average over a long period of time. Typically that unloading cycle is averaged over something like 60 seconds. And so if you're looking for 40% control, you would see 24 seconds on, 36 seconds off, and that gives you 40% of the nominal capacity of that compressor when averaged over that relatively long time. One of the challenges with this is because it has, it's effectively an on-off compressor, it just happens to be spinning the whole time, so it can stage much more frequently. It is hard on other control components, or it's harder to achieve a stable refrigeration system. Think things like TX valves. There's the opportunity for them to hunt, and that's counteracted pretty actively by things like electronic expansion valves that can understand the staging that the compressor is going through and match that capacity. The other method is inverter scrolls, and this is effectively attaching a VFD to a compressor, a variable frequency drive of some kind. And we're also starting to see now DC control of a compressor. So in the same way that an EC motor works, you can apply that same technology to a compressor. And that allows for true variable spin rate of the scroll mechanism of the pump, and very accurately control the mass flow going through. It's the most expensive technology there. And the one consideration is if your compressor isn't a matched pair with the control device you're using, the VFD or the variable speed device, you can end up running outside of the compressor envelope and have reliability issues. And you're never going to be able to run it at a particularly low percentage. And the reason for that is compressors rely on the spinning action of that central shaft for oil management and to ensure that enough lubricating oil gets throughout the moving components. And if that shaft isn't spinning fast enough, then that positive oil management doesn't happen. So lots to take in there. All of them can accurately control your space if you've got enough of them or if they're smartly designed. I went basically in order of cost to you. That happens to also generally be the order of reliability. The lowest cost tends to be the most reliable here because you've got the fewest moving parts or the fewest things to go wrong. But it also ends up the lowest control or lowest variability is at the front as well. And so for you, you need to understand in broad terms the impacts that these different technologies are going to have on your room, on your HVAC system, on how it controls your space, and understand the maintenance, the initial cost, and the control ratio that makes the most sense for you.